Today we are going to solve the problem 4.13 part 2 of Griffith third edition Introduction to Quantum Mechanics. We have already solved the problem 4.13 part 1 in which n is equal to 2 and L is equal to 0. So R to 0. So we have normalized the hydrogen radial function R to 0 in part 1. Now we are going to find the normalization constant for R to 1 where L is equal to 1. So the topic covered is we are going to find the hydrogen hydrogen atom wave function for n is equal to 2 and L is equal to 1. So we are going to focus the normalization of R to 1 using the equation 4.83 of Griffith. And we are going to construct psi 211, psi 210, psi 21 minus 1. It's a very simple. That is, if L is equal to 1, then M will be 1, 0, minus 1. It will take three values. So we are going to consider all the three values. Now our learning goal is understand the radial normalization for L equal to 1 state and apply this for spherical harmonic. You know very well the spherical harmonic will not involve change in energy. So apply the spherical harmonic to filter the full wave function and yet and explore the angular dependence for m equal to 1, 0 and minus 1. This thing we are going to see in detail in this lecture. Part P of problem 4.13 is normalize R21 from the equation 4.83 and construct psi 211 and psi 210 and also psi 21 minus 1. So the given wave function is, in fact, you can construct this wave function, a radial part of the wave function. I have given separate lecture, but here in the problem they have given the R21, which is a function of R C naught over 4a squared R e power minus R over 2a. This is given in the problem. So, in order to find the normalization constant, you integrate this. See, in for Cartesian coordinate, you know very well it is minus infinite to plus infinite. Here it is 0 to infinite, and one r square also will come because it's a spherical coordinate system. That is modulus psi squared r squared dr must be equal to 1. Then if you take the square, here we are taking radial part of the wave function and square it. So C naught squared over 16a power 4 integral 0 to infinite. Uh, Here this r is there, r squared e power minus r over a, because this 2 will go away when you are taking square of this exponential term, and already another r square is here. So naturally this will become r power 4 inside the integral. Outside I am keeping as it is inside. R squared into r squared is r power 4 e power minus r over a dr must be equal to 1. Now you take this integral part alone. This is gamma integration. If integral is of this form, that is integral 0 to infinite, Rn e power minus alpha r dr is equal to n factorial over alpha n plus 1. Here alpha is 1 over r, sorry, 1 over a alpha. Here alpha is 1 over a and n is equal to 4. So it can be written as this integral value n factorial, that is 4 factorial over alpha. Alpha is 1 over a. So 1 over a power n plus 1. N plus 1 is 5. 4 plus 1, 5. So this can be written as 4 factorial a power 5. So here 4 factorial is 24 and you have a power 5, this integral value. Now you can cancel this a power 4 uh, with this a power 5. So this will just become a, and also this is 4 and this will become 6 if you divide by 4. So then you can write 6a c naught squared. Here you have 4 over 4. Further, you can simplify this 3 over 2. So this can be written as 3a c naught squared over 2 is equal to 1. Just now we have seen 3a c naught squared over 2 is equal to 1. That means c naught is equal to square root of 2 over 3a. 2 over 3a. So we know the wave function R21 as given in the problem. C naught over 4a squared r e power minus r over 2a. So here you replace C naught. C naught is square root of 2 over 3a. Here I am multiplying and dividing by 2. So this will become 4 over 6a. And here 1 over 4a squared or e power minus r over 2a. Now what I am going to do is, this is 2 technically, square root of 4 is 2. So this 2 will get cancelled with this 4, will become 2, 2a squared. So this can be rewritten as 1 over square root of 6a uh, and 1 over 2a squared or e power minus r over 2a. And now the full wave function is psi 210, that is equal to R 21 y 10. So this is L and this is M. So now you replace R21 by this. That is square root of 1 over, 1 over square root of 6a, 1 over 2a squared r e power minus r over 2a, and y10 we have already found. Kindly refer my lecture how to construct the radial part of the wave function. I have given the link in the pinned command. So go through the pinned command and you can find the lecture link for this lecture. So which is y10 is equal to square root of 3 over 4 pi cos theta. Remember that what about y00 in the previous lecture we have seen is just 1 over 4 pi. Of course, square root of 1 over 4 pi. So there is no theta dependent here because y is L is 0. So L depends upon theta and M depends on pi. So there is no dependence. So it's simply multiplicative factor 1 over 4 pi. Now in this case you can see it's square root of 3 over 4 pi cos theta. There is a theta dependence. And remember that in this case there is no pi dependence because pi depends on the m value. M value. So now here you can simplify to some extent. Uh, that is, you can cancel this square root of 3 with the 6, which will become 2. Uh, and you can take this 2 outside. Sorry, not 2. This 4 outside will become 2. 1 over 2. So already there is 2 here. 2 into 2, 4. So 1 over 4 a squared. Here you have square root of 2a. Here you have square root of pi. So this will become square root of 2 pi a and 1 over 4a squared. This 4 comes because 2 multiplied by 2 will become. And r e power minus r over 2a cos theta. Remember that here you got theta dependence. Unlike L equal to 0, here you got only theta dependence but no pi dependence because m is equal to 0. Then we will solve the other value for m equal to 1 and minus 1. We have seen when we are dealing with the construction of angular momentum wave function. Kindly refer my lecture. I have given the link in the pinned comment. So y11, which is a function of theta and pi, is equal to minus square root of 3 over 8 pi e power I pi sine theta. Remember that here the pi also comes. And for plus 1, it is minus. That also you have to remember. The exponential term plus. What about y1 minus 1, which is a function of theta and pi? In this case, this minus will become plus. Plus square root of 3 over 8 pi. And this exponential term will become minus e power minus I pi sine theta. This I have explained in my lecture. Kindly go through it. So you can generalize this y1 plus or minus 1, which is a function of theta and pi, is equal to, here you can see, if it is plus minus. So naturally this will become minus or plus square root of 3 over 8 pi e power plus or minus I pi. Here if it is plus, you will get exponential term plus, and if it is minus, you will get exponential term minus. Sin theta you are keeping as it is. So here you have theta dependent as well as pi dependent. So the wave function psi uh, 2 1 plus or minus 1 is equal to r 2 1 y 1 plus or minus 1. So r21 we have seen this white color bond I have given 1 over square root of 6 uh, a 1 over 2a squared r e power minus r over 2a, and this one y1 plus or minus 1, which I have shown in the yellow color bond. So this is the full wave function with the value y n is equal to 2, l equal to 1, and m equal to plus or minus 1. If you find this lecture helpful one, kindly subscribe my channel. Also share my channel and join my channel for the growth of my channel. Thank you very much for continuously watching my video and supporting me continuously. Thank you very much.